Hello everyone, myself Kalachalvi, working as an assistant professor in the Department of Mechatronics Engineering, SNS College of Technology for past 10 years. So today we will discuss an important topic in electrical drive, loading conditions and classes of duty. Understanding how the load varies on a motor over time is very essential for proper motor selection, thermal performance optimization, efficient and safe operation. So loading condition refers to the variations of load demand on a motor with respect to the time. So loading condition and classes are having the another important term, that is duty cycle. So this duty cycle is a pattern of loads, speed and then temperature. So there are two major types of loads are there. First one is constant torque load, another one is variable torque load. In this constant torque load, torque remains approximately constant regardless of speed. Example, conveyor, hoist, compressor and crane operations. These applications are require uniform torque throughout the operation. So variable torque load, in this type, torque varies with speed, typically proportional to speed squared. For example, fans, blowers and then centrifugal pumps, axial flow pumps are the examples for this second type. And important relationship between the two types are load directly proportional to the speed square. So this distinction is very important for motor selection. So before selecting a motor, we have to follow the design thinking concept. The stage one is empathy. So we must identify the application domain and start stop frequency, observe the speed variations, analyze the ambient conditions. So we also estimates the peak load, thermal behavior and the type of operation. Now we define key duty parameters, that is on time and off time, load duration, cycle repetition and then torque speed relationship, thermal time constant. These stage converts the observation into engineering requirements. So here is the loading conditions of different types, and then motors are classified into standard duty cycles, that is from S1 to S8. Here we have to see about the S1 to S3. That is, S1 is a continuous duty. Motor runs continuously and operates long enough to reach thermal equilibrium, and temperature becomes constant. So duration is effectively infinite. Here example for S1 is conveyor running continuously. Conveyor running the continuous motion is example for that one. S2 is short time duty. Here motor runs for a short time, which does not reach a thermal limit, then motor is switched off for a cooling. Gate motors and valve actuators are the short time duty only. Third, S3 is a intermittent periodic duty. So here repeated start stop cycles are there, which includes the rest periods. There is no electric braking. So heating depends on the duty cycle percentage. So S4 is nothing but intermittent with starting, which includes the starting current effects, and then heavy starting losses, rest period presence. There is no braking in this duty cycle, which is used where frequent starting occurs. So SY is intermittent with electric braking, which includes both starting and electric braking. There are regenerative braking is also possible. Energy recovery happens in this duty cycle, which is used in advanced drive systems also. So S6 is nothing but a continuous with electric braking. So motor runs continuously in this type, and occasional braking intervals are there. There is no rest periods are here, which is used where the smooth continuous motion is required. So here S7 and S8 duty cycles, and then S7 is a starting and braking duty. Frequent starting and brakings are there in this type. There is no rest periods are there. Heavy inertia loads are here. Non-periodic nature of this starting and braking duty. Rolling mills, heavy cranes, or these types only. Final one is non-periodic duty. So this non-periodic duty is a most complex duty compared to other seven. So here there are having the variable load, variable speed, possible overload, and there are no predictable cycles. So now the modern automated industrial drives or these types of duty cycles only. So after defining duty, we move on to the final stage, ideate and prototype testing. So for ideate, we improve the speed torque profiles, use the smart starting methods and apply the regenerative braking. For the testing operation, we perform the load simulation, temperature monitoring, cycle durability testing. Likewise, this ensures the reliable drive designs. So we coming to the summarization. So let us summarize the content. Loading conditions describes load variations with time. There are two main types of loads we had seen in the previous slides, that is constant and variable torque. There are 8 duty cycles are there, S1 to S8, which defines the motor operation cycles. So correct duty selection, which improves the motor life and efficiency. Here the design thinking concept ensures the systematic motor selection. So the final key takeaway of this PPT is always match motors duty cycle with the application load parameters and then application load patterns. Thank you.